Good evening, ladies and gentlemen. It is a Wednesday night, and of course that means that AE 911 Truth is back with a series of webinars, and we're bringing back tonight Jonathan Cole. He has been a registered professional engineer for over 35 years, and like most Americans, he believed the official version of what we were told for many years. Then, in late 2007, he started to do some research on how the buildings fell and realized that something was very wrong with the official story, like so many of us. And in 2010, he began conducting real-world experiments and making videos to either prove or disprove what we were being told about the event, focusing on the Twin Towers and Building 7. Now, John was one of many experts who spoke at the 2011 Toronto hearings on the events of September 11th, and was also one of the 23 members of the 9/11 Consensus Panel, co-founded by David Ray Griffin and Elizabeth Woodworth. His experimental work, as well as other videos, can be found on YouTube under the name Physics and Reason, the website 911speakout.org, and, of course, on Architects and Engineers for 9/11 Truth's website at ae911truth.org. So 2 weeks ago, he presented part 1 of this series about the motions observed with the Twin Towers fall, and tonight he'll be presenting part 2 of the series. It's entitled 9/11 and the Scientific Method, Part 2, Temperature. So let's go ahead and add him in. And when doing that, I just want to remind people that we will be taking your questions at the end of John's presentation this evening. Best way to submit them is just to go to the YouTube chat box, write question before it, and write your question. I'll see it better that way. And if you're an engineer and want to get credit for viewing this presentation, all you need to do is visit our continuing education page at ae911truth.org/CPD. Take a short quiz. You get 4 out of the 5 questions right, and you'll get your credit for viewing tonight's event. So make sure you do that if you want that credit. So that's the end of my part. I'm going to turn it over to John. John, take it away.
All right. Well, thank you, Andy. Yeah, a couple weeks ago, we were looking at mostly the motion that we saw on 9/11, and we kind of focused on the Twin Towers. We looked at just Tower 1. 9/11, the science of 9/11 is such a big topic, I had to split this thing into 2 separate webinars. So tonight, we're going to be talking about temperature. That sounds kind of like a funny thing. Well, why would you talk about temperature? Well, we're going to show you some evidence where there was some unusual temperature. When I say temperature, I mean high temperatures. So let's jump into this. So there's all kinds of collapses. There's building collapses, unfortunately, that happen all the time. Us engineers try to resist all the forces that can be on buildings, but there's all kinds of very strong forces, such as earthquake collapses. This one here happened in New Zealand about around 2010, 11, 12, something like that. And then just last year here in Florida, what's called the Champlain Towers South, that was a partial collapse, not of the entire building, but of a good section of it. A lot of people died there. That's still under investigation right now. And you can see some pancake floors right here with these investigators standing on top of that. And then lately, it seems like I've been a member of the Hurricane of the Month Club here in Florida. We've had 2 hurricanes, Hurricane Ian, and then Nicole last week, which was one reason I wasn't on. But there was nothing unusual in all 3 of these types of collapses. There was no evidence of anything unusual, and there was also no what we call high order damage. Even though it looks like a lot of damage here, they really weren't considered high order damage. Well, what is high order damage? Well, the National Fire Protection Association, you're going to hear the words NFPA, that stands for the National Fire Protection Association. That is a well-known guide. If you're in the building industry, or if you're in the code enforcement industry, or if you're in the fire prevention industry, you're well aware of what's called NFPA. They make a lot of different guides. One of the guides they make is called NFPA 921. In one section of that is what's called high order damage. Well, according to that, they say high order damage is characterized by shattering of the structure, producing small pulverized debris. Walls, roof, and structural members are splintered or shattered, with the building completely demolished. Debris is thrown great distances, possibly hundreds of feet. High order damage is a result of rapid rates of pressure rise. Okay, well, with Tower 1 and Tower 2, it looks to me like there was some high order damage. I mean, there was massive pulverization and a lot of the debris was thrown outside the footprint. Here's a nice still picture of it. But if you go back and you look at the demolition or the destruction of towers 1 and 2, they're both similar. It fragmented a lot of the material into very small bits, into dust and very small parts. We looked at this in depth 2 weeks ago in my motion webinar. Well, the same thing with building 7.
Third time today. It's reminiscent of those pictures we've all seen too much on television before, when a building was deliberately destroyed by well-placed dynamite to knock it down.
Did they actually use the word brought down, and who was it that was telling you this?
The fire department. And they did use the word, we're going to have to bring it down.
So building 7, as you can see in this picture on the right here, that was also pretty well fragmented. That was brought down a different type of, didn't look the same as buildings 1 and 2, but that one looked very, very unusual. It looked pretty much exactly like what you would see when they bring down buildings in Hollywood. It came straight down, basically in its own footprint. And it actually came down at free fall acceleration, meaning a portion of that time it dropped down just as fast as you could drop a rock. So there was also a lot of evidence of explosions that we heard that first day. So this was on September 11th. This is just some of the news media that reported devices that were planted in the buildings and explosions that were going off. Let's see what they said back then.
Actually, devices that were planted in the building. There was another explosion that took
Second explosion.
Had that big explosion. Heavy-duty explosion. Some of the people out, then there's those secondary explosions. An explosion blew and it knocked everybody over. Huge explosion that we all heard. Big explosion. An explosion. And another explosion. A lot. We heard a big explosion. Big explosion. Explosions. Of the explosion.
So everybody that day was talking about explosions and explosive devices. And that was really the dominant theory. We didn't hear anything after that after September 11th, but that was the thing on September 11th. There were so many eyewitness accounts. Now, these firemen were there. They also heard explosions, and they talked about detonators. What did they say?
Floor by floor, instead of popping out.
It was if they had detonated. If they were planned to take down a building. Boom, 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 boom.
They also saw, in addition to explosions, they also saw molten metal or molten steel. And they talked about that during the cleanup process. They saw ample amounts of molten steel, which they've never seen before in a normal building that came down due to fire.
You'd get down below and you'd see molten steel running down the channel rails. Like you're in a foundry. Like lava on a volcano.
Now, NFPA 921 in their guide for fire and explosion investigations, there's different chapters for that. So, for example, whenever something big like this happens, you're supposed to preserve the fire scene and the physical evidence. The entire fire scene should be considered physical evidence and should be protected and preserved. 9.3.6 talks about spoliation of evidence. Evidence should be maintained and not be destroyed or altered until all others who have a reasonable interest in the matter have been notified. Section 18.12.2 talks about high explosives. They even have a section on extremism because, remember, these towers were hit in 1993 by a bomb. It says the terrorist may include fire, but as one of a variety of weapons, along with explosives and furthering his or her goal. In section 18.15, they talk about analyzing the fuel source, and they say all available fuel sources should be considered and eliminated until one fuel can be identified as meeting all the physical damage criteria. Okay. Well, it turns out that the mass murder of thousands of people on 9/11 was like almost 3,000, 2,700, I think, something like that in the towers. Well, that wasn't considered a crime. So the fact that we lost all these people due to allegedly 19 hijackers, that was never considered a crime. And because it wasn't considered a crime, it was never investigated as a crime. And the evidence was destroyed almost as fast as possible. It was swept out of there relatively fast for so much material being there. And all those NFPA guidelines I just mentioned, well, they were completely ignored. Let's listen to someone here talking about this.
We pressed early on for for a full-scale investigation. And of course, one of the issues was while we were doing that, the evidence from the buildings was being destroyed as we were talking about it.
So the evidence was being hauled off and being destroyed. Now, there's a lot of evidence. Some of it we talked about 2 weeks ago. One of the things we talked about 2 weeks ago was what I call the spire, what others call the spire. And that was the inner core columns that eventually fell after the rest of the tower fell. All the floors were down, and there was these inner core columns that never came down. Before this spire came down, these inner core columns, there were some pieces of core, inner core, these cores were big box columns, that looked like they were cut like a tree. Okay, so we saw cut steel falling from this core, okay? And then we saw on ground zero all kinds of cut up steel, all in almost the same amount of length at ground zero. So that's kind of interesting evidence. It's just more evidence. Also in the dust were what's called iron-rich spheres. And they were found all through the dust, and they were found by different entities out there. Wasn't just NIST that found them. Matter of fact, NIST, National Institute of Standards and Technology, they didn't find any because they didn't look for them. But there were other studies that were done. One was called the R.J. Lee report. They say particles of materials that have been modified by exposure to high temperatures, such as spherical particles of iron and silicates, are common in the WTC dust, but are not common in normal office fires. Well, that's odd. Why would it be in this one, but not in normal office fires? The USGS, they also reported, they had what's called the Particle Atlas of World Trade Center dust. They identified metal or metal oxide in the World Trade Center dust and presented micrograph of these particles, 2 of which were labeled iron-rich spheres. And this is kind of a picture of it. They're round iron-rich spheres. Well, a couple questions come up. First of all, why were they round? Any of you that are into shotgunning are well aware of different size pellets that go in a shotgun shell, whether it's 8 gauge or 6 gauge or double-aught buck. Well, they used to be made out of lead. And the way they would make them is they would take, this is a shot tower, they would take and they would heat up molten lead, and they would drop it through a screen, different size screens for the different size shot. And as that molten lead fell through the air, because it was molten, it would pull into a sphere, okay? And surface tension would automatically pull it into a nice round sphere. Okay, and then when it hit the bottom, it would hit water and they would cool, and then you would get your shotgun shot. Now, in order for it to be a sphere, it had to have been molten, okay? The other question was, why were they iron? Why weren't they steel? So these are kind of interesting questions. This is evidence that came up. They were round spheres of iron, not round spheres of steel. Also, evidence that was being built over time was that there was what's called NASA thermal imaging. NASA took some photographs of ground zero, and they noticed that ground zero was pretty hot in that area for a week or two after that, which was pretty unusual for just a standard office fire. Also, excavators pulled out large chunks of red hot material. And like those firefighters say, there was actually flowing molten steel that was caught on camera in these excavators as they excavated these fires. So all these were kind of interesting bits of information of extremely high temperatures. There was also evidence of molten steel from many, many sources. Here's just a few of them just kind of put together that we heard of at one time. So these are just evidence of molten steel.
Very intense down there, and actually melted beams where it was molten steel that was being dug out.
This fused element of steel, molten steel and concrete and all of these things all fused by the heat into one single element.
And almost like a chunk of lava from Kilauea or Iceland, where they're very sharp but breakable shards on the end here.
This 8-ton steel I-beam is 6 inches thick. It was selected to be preserved for future generations for the near-perfect horseshoe-like bend formed during the collapse.
I found it hard to believe that it actually bent because of the size of it and how there's no cracks in the iron. It bent without almost a single crack in it. It takes thousands of degrees to bend steel like this.
Typically you'd have buckling and tearing on the tension side, but there's no buckling at all.
You saw steel, some of the thickest steel I've ever seen, bent like a pretzel. And you just couldn't imagine the force that took. The grapplers were pulling stuff out. big sections of iron that were literally on fire on the other end. They would hit the air and burst into flames, which was pretty spooky to see.
There was even a point where you would create an air pocket by moving steel, fueling the fire underground, would ignite cars and cars would just blow up. But you know, these underground fires were just like the fires of hell.
This is how it's been since day one. Oh, it's unbelievable. And this is 6 weeks later, almost 6 weeks later. And as we get closer to the center of this, it gets hotter and hotter. It's probably 1,500 degrees. We've had some small windows into what we thought was a core at some point, and it looked like an oven. You know, it was just roaring inside. And it's just a bright reddish orange color. See that stuff he's pulling out? What was that, Chief? We're gonna hold off on the water. See the stuff he's pulling out? Yeah. Red hot. If we hit it too much steam, you won't be able to see what he's doing. Great.
You see how this debris is still smoking? That's from the fires that are still burning. 8 weeks later, we still got fires burning. Every now and then, one of the pieces of equipment will dig in, they'll open up a small area, the oxygen will rush in, and you'll get this plume of brown, black smoke coming up. That's because that fire just got more oxygen. So, I mean, these things are burning. At one point, I think they were about 2,800 degrees.
Underground, it was still so hot that molten metal dripped down the sides of a wall from Building 6.
There were fires of 2,000 degrees Fahrenheit below the ground.
And all of a sudden, he comes out of this little tunnel screaming, "Wait till you see what I found." And he pulls in ministers and officials, and there, this cross is fully extended, melted together with the intense heat. The two beams were never initially part of the same structure. Heat literally melted them together. And the piece of metal that's draped over was molten metal that had literally fallen over one of the arms.
Steel-toed boots is one of the biggest things.
Steel-toed boots?
Steel-toed boots. Out still on the rubble, it's still, I believe, 1,100 degrees. The guy's boots just melt within a few hours.
It was literally steaming. Your boots would melt in certain areas. That's how hot it was. The steel was coming out red in certain areas from the first couple of weeks.
So there was ample evidence of molten steel. Well, what's the big deal about molten steel? What's the problem with that? Well, the problem is the temperature that it takes to melt steel with office fires. Now, aluminum will melt. I'm an American, so I'm going to use Fahrenheit, but I've also done a conversion here to centigrade. Anybody used to using centigrade. But aluminum melts somewhere around 1,220 degrees Fahrenheit. Now, the maximum office fire or a jet fuel, you say, well, there was a jet there, so we had some jet fuel there. Well, the maximum temperature for an office fire is somewhere around 1,800 degrees. And some have speculated that it's pretty unlikely that it got anywhere over, say, around 1,470 degrees. But I'm going to use 1,800 degrees because that's about the maximum temperature that an office fire can get to. Well, the problem is steel and iron, that doesn't melt until about 2,700. Depends on the type, whether it's iron and what type of steel it is. But let's say 2,700 degrees to 2,900 degrees, or almost 1,000 degrees hotter than the maximum possible jet fuel fire or office fire. So the problem is jet and office fuel fire cannot melt steel, and yet we had ample evidence of melted steel out there. So it's a big problem for the official story. This is molten aluminum being poured, and this is molten steel or iron being poured. Now, the fact that a steel frame building will not melt or collapse is exactly why firemen go into steel frame buildings to put them out. They'll rush into those steel frame buildings. They know they're not going to be melted because it's impossible. An office fire cannot melt steel frame buildings. So that's the problem with all this overwhelming evidence. Well, Congress was getting a lot of pressure. Nothing was being done for a while as far as looking into what really happened on 9/11 with those buildings. So they tasked what was called the National Institute of Standards and Technology, or NIST. You're going to hear me talk about NIST a lot. They tasked them to determine why and how World Trade Center 1 and World Trade Center 2 collapsed following the initial impacts of the aircraft. So NIST spent about 3 years and about $16 million studying this thing. And NIST has some of the top scientists in the world. After their complete investigation, I talked about this even more a couple weeks ago, they brought the collapse up to what we call collapse initiation, but they said they were unable to provide a full explanation of the total collapse. That's kind of odd. Here we have the largest mass murder, or the largest, one of the largest structural failures ever, and they could not provide a full explanation of the total collapse. Now, it wasn't just NIST that put this massive study together. This study was huge, maybe 10,000 pages. And it was broken into several different segments. Many private engineering firms, materials firms, construction firms, they helped put this investigation together as subconsultants. The interesting thing here is that all that work that they did, nobody signed and sealed any of those reports, at least that I could find. And the final report was not signed and sealed. And normally when you sign and seal a report, it just puts some sort of responsibility on the individual putting that report together. But nobody signed any reports that I'm aware of in the NIST investigation of the towers. They also put disclaimers on most of them, on most of the cover sheets. They said no part of any report resulting from a NIST investigation into a structural failure from an investigation under the National Construction Safety Team Act, which, by the way, that was the act that Congress enacted, may be used in any suit or action for damages arising out of any matter mentioned in such a report. So there was really no responsibility and no liability. And as you go through these reports, and I'm going to just do some small clips of these reports, they tended to use a lot of things that may have been technically true, but they were misleading. And they use what I like to use, I use the word wiggle words. They use a lot of wiggle words in their reports to kind of sidestep or mislead a little bit, in my opinion. That's just my opinion. So, for example, they had what's called frequently asked questions. One of them was, what did the NIST investigation not consider reports of molten steel? I'm sorry, why did the NIST investigation not consider reports of molten steel in the wreckage from the WTC towers? Remember all those reports of molten steel? Well, they said they found no evidence that would support the melting of steel in a jet fuel ignited fire in the towers prior to collapse. Well, that's technically correct because a jet fuel ignited fire doesn't burn hot enough to melt steel. So they kind of sidestep this thing, but they, every average person reading it say, oh, okay, well, they didn't find any evidence of a jet fuel ignited fire. What they didn't say is that maybe it wasn't a jet fuel ignited fire. They also said the condition of the steel in the wreckage of the World Trade Center towers, for example, whether it was in a molten state or not, so they're kind of hedging about even if it wasn't a molten state, well, that was irrelevant to the investigation of the collapse since it does not provide any conclusive information on the condition of the steel when the towers were standing. So what they're saying is that, well, even if you found all this molten steel in the wreckage, that doesn't tell us anything as far as when the towers before they fell, and that's the only thing they investigated. Well, using that same logic in a murder scene, you could say that any bullet found would be irrelevant to the murder investigation since it does not provide any conclusive information on the condition of the body when the victim was standing. Now, NIST also denied the presence of molten steel. They knew they could never acknowledge molten steel because molten steel would be the kiss of death to their whole fire-induced collapse theory, because office fires cannot melt steel. So they denied any presence of it. This is Dr. John Gross. He was one of the lead investigators. This is him during a presentation he made at one time.
Premise that there was a pool of molten steel. I know of absolutely nobody, no eyewitness who said so, nobody who's produced it. I was on the site, I was on the steel yards, so I don't know that that's so.
There's video of it.
Melted around 2,600 degrees Fahrenheit. I think it's probably pretty difficult to get that kind of temperatures in a fire. So I don't know the basis. I can't address your question if I don't know the basis.
Well, NASA pictures, thermal images showed those sorts of temperatures in the basement.
Could you send them to me?
Okay. My name is Mark, and I'm the individual who was questioning Dr. Gross, and he asked me to email to him those thermal images. When I approached him after his talk to get his email address for that purpose, he refused to provide it to me. I think this is important because it reveals the attitude of the NIST investigators, which is one of willful ignorance of what really happened on 9/11.
So Dr. John Gross, that was for his NIST report. He was also involved in what's called the FEMA report, which was done earlier. It was a FEMA ASCE report. And he's right. He was on those steel yards. As a matter of fact, there's a real nice picture of Dr. Gross. Here's Dr. Gross looking at the camera in a nice pose. As this was done as part of his FEMA investigation. Now, maybe because he was looking at the camera, he didn't notice that this melted steel wide flange section was here right in front of him with holes in it and all eroded and melted away. So, or maybe he forgot that he was part of that investigation, didn't realize that that was a piece of melted steel right in front of him. Now, the problem with melted steel over the years was so obvious that memes were made all over the internet. Okay, and some of you probably heard of these. Jet fuel can't melt steel beams. You can buy these on Amazon right now. Jet fuel can't melt steel beams. The purpose of that meme is to bring to light that if it was just jet fuel or an office fire, and if there was a lot of melted steel found, well, the office fire and the jet fuel couldn't have done it. Something else must have melted that. And that's sort of the elephant in the room. That's what all the investigators are trying to ignore that question. But these memes came out about melted steel in those high temperatures. Now, over time, we were given about 7 unofficial theories of why those twin towers came down. And I went through these in detail 2 weeks ago with my motion webinar. And just going to go through them real quick here. We're not going to reinvent the wheel here. But basically, we had that devices planted in the building, those explosions that we heard the very first day. Early on, we also heard about the melted steel theory, where a lot of professors were saying, well, the plane's hit and it melted the steel and it brought it down. Problem, again, is that jet fuel can't do that. We heard about the pancake theory. We also talked about the crush down, crush up theory, where a smaller piece crushed it all the way to the ground and then it crushed itself back up. There's also what's called the directed energy weapon theory, or the DEW theory, where the steel was as Dr. Wood says, dustified. And that was a theory where there's basically these energy weapons somewhere outside the building shooting at this thing and turning the steel into dust. There was also a theory that came out called the mini nuke theory, where there's nuclear bombs planted in there. And then another theory that came out in, I think, 2011 was called the aluminum sprinkler theory. And that was where the aluminum from the airplane that melted, and then that dropped down and hit the water from the sprinkler system, and that's what exploded and brought the towers down. Those are all unofficial theories. None of them are official. The only official government report that really focuses on this is that NIST report we talked about that came out in 2005. And their report, they have no total collapse theory at all. Again, isn't that odd? They studied it for years and they have no theory at all. Well, all of these 7 theories and the non-theory, they can't all be right. So the question is, which one is the most correct? Well, in order to determine that, the right way to do it is use what's called the scientific method, okay? And that scientific method can be summarized here. The first thing is you ask a question. It's like, well, geez, where'd that molten steel come from? Then you do background research and you collect all the available data that you know of, okay? Anything that would apply to the question that's asked. Then you build your hypothesis to come up with a mechanism to describe what you see, what all that evidence is. And then probably the most important step is you test your hypothesis by doing an experiment, a real world experiment. You analyze your data and you draw a conclusion and you report your results. And the only way you know if your hypothesis is correct is if it matched the experiment, a real world experiment. Now, Richard Feynman, I touched on this earlier 2 weeks ago too. He was a physicist. He was also, he was part of the Rogers Commission looking into the Challenger explosion in 1986. But he was a nuclear physicist. He got the Nobel Prize in 65 in theoretical physics. He understood how important experiment is. He knew there's a lot of theories out there and there's an awful lot of talk, and talk is pretty cheap. And this is what he said in front of his class. He's trying to drive home the point on how critically important a real world experiment is.
If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, wrong. That's all there is to it.
Because an experiment kind of cuts right through all the equations and all the models, all the computer models. That's why, because experiment is nature. It's what nature does. And we're trying to understand what nature does with all our math and our computer models. Well, let's get into some experiments. Now, one of the things that happened before Tower 2 came down is there was this flow of this orangey, yellowy material that came out just before it fell. And this was about 7 minutes before the onset of the final collapse. And here it is on this side here. It's falling all the way down to basically down to the street level. And it trailed all this yellowish material coming down as it fell. And so it was kind of interesting. Cameras picked up on that and was wondering, well, what is that stuff? Here's a video of it that was caught. Here it is. This is floor 80 at a Tower 2, and there it is flowing down, which was most unusual. Well, the first question we want to ask is, what color is that metal? Because the color of that metal is an important factor in understanding what it is. Now, this is going to seem kind of silly, but there's a kind of a reason why I'm asking this thing. Would you say that, as you look at that, would you say, well, that looks kind of green or greenish to me? Or does it look kind of silvery to you? Maybe it's bluish, or does it look maybe kind of yellowish to you? Now, I'm assuming we all have normal vision. If you're colorblind, I apologize, and you can't answer this question. But if you have normal vision, you should be able to tell what color that is. Well, the lead investigator was Dr. Sunder for this NIST report. He was on a radio program, and he told us what color he thought this was. Now, again, it was very, very important for them not to acknowledge molten steel. Again, molten steel would be the kiss of death for an office fire or a jet fuel fire. So sometimes it slipped out and they'd have to backtrack a little bit, but they never wanted to mention the words molten steel. So this is him on a radio program. Let's see what he thinks this color is.
Seen on the northeast corner of the 82nd or 81st floor of Tower 2, some minutes before the building collapsed. That was an isolated incident where molten material, not molten steel, molten material was seen coming out. It was a silverish color molten material. Okay. And this is...
So he says it was not molten steel. He slipped up there and he backpedaled. And he also said that it was silverish in color. And the color of this, again, is kind of an important key piece of evidence here. So he says it's silverish. I think it's more yellowish, but that's me. So let's eliminate the green and the blue. And let's only compare silver and yellow. So in the middle here, here's a still photograph of this molten metal, that he calls it. Doesn't say molten steel. He calls it molten metal from World Trade Center 2. Here's a picture of it here. Here is molten aluminum. And to me, this looks silverish here. And then here is a foundry with molten steel or iron. So the question is, what color does this match better? Does it match the silvery color or does it match the molten steel and iron? Now, if you said it matched the molten steel and iron, because it looks more yellow, well, then that means that you could be a conspiracy theorist, because what that means is that normal office fires probably didn't bring down those towers. So, like I say, if you think that's yellow and more like molten iron and steel, you're probably a conspiracy theorist. So you would be labeled that if you start pointing that out. Now, if you're unsure, if you're like, well, I don't know, he just told me it was silver, and the experts are telling me it's silver, although it sure looks kind of yellow to me. But if you're unsure, I recommend that we ask a 5-year-old, because a 5-year-old, one of the first things we develop is understanding colors. We understand that before we understand numbers. And 5-year-olds tend to blurt things out. You know the story of the emperor's new clothes. Well, they would just blurt out, well, of course that's yellow. Now, in one of the NIST frequently asked questions, they sort of backpedal, and they do say, well, they say, why do some photographs show a yellow stream of molten metal? There's the word yellow. So they are acknowledging it. Yeah, I guess it is yellow. Well, why do they show a yellow stream of molten metal pouring down the side of World Trade Center 2 that NIST claims was aluminum from the crashed plane, although aluminum burns with a white glow? Well, these are excerpts from their response, and they said, NIST concluded that the source of the molten material was aluminum alloys from the aircraft. So they're still saying that was aluminum. They said pure liquid aluminum would be expected to appear silvery. I agree with them. We would expect it to appear silvery. They then said that however, the molten metal was very likely mixed with a large amounts of hot, partially burned, solid organic materials, such as the desk, the furnitures, the carpet, the partitions, and the computers, which can display an orange glow, much like the logs burning in a fireplace. So this is their explanation for what we saw coming out of Tower 2. I call it the molten aluminum office furniture theory. That's their theory, that it was office furniture mixed in, and it was that office furniture, those desks and chairs, that made that yellowy material that we saw coming out of Tower 2. Well, let's think about that for a minute. Okay, let's talk about the NIST molten aluminum office furniture theory. Well, if you look up the density of aluminum, if you took a box of aluminum, say 12 inches by 12 inches by 12 inches, and you tried to pick up that box of aluminum and it was molten, that thing, if you put it on your bathroom scale or tried to pick it up, that would weigh about 169 pounds per cubic foot. Again, I'm American, so I'm using pounds per cubic foot. Now, if you picked up the density of wood, pretty heavy wood, I used to do quite a bit of woodwork, work in the woods, or if you grab a load of firewood to bring into your house, if you took a 12 by 12 by 12 square of wood, that's about 50 pounds per cubic foot, or about less than a third of the density of aluminum, right? Well, office furniture, okay, or carpets and partitions and computers, well, that would probably be a lot less than 50 pounds per cubic foot. So the problem is when you have different densities, they won't mix, okay? So any furniture in a molten soup, if you will, of aluminum, well, that would have popped out of that molten aluminum like a beach ball in a swimming pool. And then it would have burned off at that temperature, maybe with some burning orange embers, but the aluminum would have still poured silvery, okay? Now they say, well, like I say, sometimes they use some wiggle words. Using pseudoscience, maybe it was very likely mixed, but using physical science, mixing of materials with big differences in densities is actually the least likely that would happen. And here's just a photograph of this is mercury, happens to be mercury with a pool ball, just kind of demonstrating the principle of differential densities, okay? With the pool number 3 ball there, that floats pretty well on this mercury. And yes, mercury is heavier than aluminum, but still wood is much lighter than liquid aluminum. So that's the first problem. Well, let's do an experiment. Just because I say that doesn't mean it's true. So we really should do an experiment to verify this. Well, I didn't do an experiment, but Professor Stephen Jones, he provided an experiment because NIST, even though they said those words, they never provided an experiment to show us what that aluminum furniture theory would look like to prove it. So Stephen Jones did. And in fact, what we see is poured silvery aluminum with the organics burning off. Here it is. Here's Stephen Jones.
Okay, we can go again. Yeah, go ahead. Okay, that's all we can do. That's good.
So as the material poured, it didn't stay mixed and it poured silvery. It did not pour yellowish. Well, NIST also mentioned computers. What about computers? Okay, a lot of us have Androids or iPhones. I got an iPhone, happen to have an iPhone. iPhone is probably denser than the average computer back in 2001. Would you agree with that? Well, here's an experiment that was done. I did not do this experiment. This was done. This is on YouTube. It's called The Backyard Scientist. And when I show these other people's experiments, that does not mean by any means that they're endorsing what I'm saying. However, they don't need to. We're just seeing what nature does. So here's an iPhone that's dropped into molten aluminum. And we're going to find out pretty much what I'm saying, that it's going to float.
Oh, wow. Let's flip it over, see what it looks like. Whoa, whoa.
It looks like a freaking Terminator.
It does look like a Terminator.
It's also bendable. Did you see when you pressed it? It like bent in.
You know what's cool is it floats. It pops right back up to the surface. Can you believe that this is an...
He's right. It floats. And that's the problem with the office furniture mixture theory. Well, okay. Well, what if that aluminum was heated a lot hotter than just its melting point? What if it was heated up to 1800 degrees? After all, we said that probably the maximum office fire is somewhere around 1800 degrees Fahrenheit. Can't get any hotter than that, nor can a jet fuel fire, a diffuse jet fuel fire, which we're going to talk about later. Well, again, aluminum, the melting point is around 1220 degrees Fahrenheit, right? A maximum jet fuel or office fire is around 1800. Well, the problem with this theory is actually twofold. Number one, try heating water from a melted ice cube on the floor. Remember, this was pouring out from the floor in that 80th floor. Okay, heat it with an open flame. Say you want to heat it another 100 degrees or so. So here's some ice cubes. They're laying on the floor. But then what happens as soon as it melts? It'll run and it'll spread as soon as it melts. And gravity's going to pull it to whichever way that floor happens to be sloped, or it'll just puddle up there. So the only way to heat it is to contain it somehow. Okay, if you want to bring this water up to boiling point, you got to kind of contain it because it's spreading out so fast. Well, there were no containers that I'm aware of on the 80th floor. The other problem is, and I touched on this 2 weeks ago, NIST in their report, they came up and they put together what they call their probable collapse sequence. Okay, and they said in their sequence of how those towers came down was that the floor trusses between the perimeter columns and the core columns, well, they sagged and they bowed, okay? They didn't break, okay? So if that's true, we saw that molten metal near the edge. So if anything was starting to melt, a piece of that Flight 175 that hit Tower 2, if that material was starting to melt, why wouldn't that flow back away from the perimeter columns? Well, we saw it pouring out of the perimeter columns. So you would think that if their theory's right, and this thing's starting to bow, once it started to melt at 1200 degrees, way before it could have gotten to 1800, it would have flowed away from the perimeter, not toward the perimeter. Now, the other thing with molten aluminum, let me get a little sciencey here. Aluminum there's different properties to metals, okay? And there's what's called emissivity and reflectance, okay? Well, emissivity it's a coefficient somewhere between 0 and 1. It isn't 0 or 1, but somewhere between them. And it's a property that relates how well a material radiates its own energy compared to a black body. Okay, and there's what's called the Stefan-Boltzmann law. Now, the emissivity of aluminum is lower than that of cold rolled steel. There's a little table put together, and it depends on whether the aluminum is oxidized or whether it's rough or whether it's smooth. There's different numbers, okay? And this is some of the emissivity of aluminum. Cold rolled steel is much, much higher. There's also what's called reflectance, and that is pretty much what it sounds like, the effectiveness of a material to reflect radiant energy back, okay? Well, aluminum has a high reflectance, much higher than carbon steel, and there's different wavelengths, okay? There's the infrared wavelength, which is a longer wavelength, and then the visible light spectrum is very, very narrow, the stuff that we can see, all right? So the reflection for aluminum, what's called a reflection factor, for whether it's matte aluminum or polished aluminum, they're somewhere in the 55 to 87 reflection factor. Stainless steel, which is pretty bright steel, well, that's less than aluminum, almost any aluminum. So molten steel, which is kind of blackish, that would be even lower. So the problem is aluminum has a low emissivity, but a high reflectance, okay? And in all wavelengths, carbon steel is lower than aluminum. All right, well, what does all that mean? Okay, well, what it means is that aluminum, if you superheat it above its melting temperature to 1800 degrees Fahrenheit, it can indeed appear yellow, but only if it's in a container or only in a dark area, but not in sunlight, okay? In superheated aluminum, if any superheated aluminum poured and falling in sunlight after a short distance will still appear silvery and not yellow, okay? So as this is coming, and the reason is we're getting sunlight that bounces off that silver, bounces off that aluminum, which has a high reflectivity, but it has a low emission of any kind of temperature in there from the heating of it. So the reflective capacity of it exceeds the emission capacity of it. So any falling molten metal, okay, this falling molten metal, it's not aluminum. That's impossible because it defies those physical laws I just mentioned. Now, let's look at this a little bit further. Let's look at an experiment. The heck with what I was just saying. Let's look at an experiment. Again, I got this off YouTube. This is somebody, their YouTube handle is 8Real. I don't know who this gentleman is, but he put together a short video that demonstrates this property of pouring silver even at superheated temperatures, way above its melting point. So here's a video of that he put together. Again, this does not mean he supports what I'm saying. It's just this is what nature does when you superheat and pour silver. Let's listen to him.
Okay, that's 2000 series alloy. I do believe it's 2224. Piece of stock I got from work. Fellow on YouTube said I should visit a foundry. I got one right here in my kitchen. When this gets up to about 1800 degrees, which is what the set fires were, we'll go ahead and pour. There we go, about 1821. 1822, I think we're about ready to pour it. That's steel. Yes, it does bend. Okay. Are you ready? There we go. This is aluminum, folks. Here's what it looks like. There it is, folks. Yeah. What color is that?
Okay, so again, you'll notice this container was orangey. Okay, but as soon as that aluminum started coming out, the sunlight would hit that and it would reflect back, eclipsing any kind of orange color it has. So poured aluminum in sunlight, like this right here, will not look like that. It'll look silvery, and that is not silvery. Now, regardless of what I'm telling you here, you would think, this is such an important issue, you would think after 20 years, somebody would do an experiment showing superheated aluminum to 1800, poured in sunlight, and that's the key, being yellowish, but they can't because it defies nature's laws. It always pours silvery. All right, let's move on to the next topic. Okay, the next topic is what I call the mysterious eutectic steel experiment. This is one of my earlier experiments I put together. Just a little bit of background. As part of that FEMA report, Worcester Polytech, that's up in Massachusetts, there were some professors that went out and they grabbed some samples from Building 7 and also from the towers. They found a 1-inch thick steel column from World Trade Center 7 reduced to a 1/2-inch thickness with gaping holes, curled like a paper scroll, thin to almost razor sharpness with a Swiss cheese appearance. It was very unusual for an office fire. The FEMA report, Appendix C, okay, they said that evidence of severe high temperature corrosion attack on the steel, including oxidation and sulfidation, with subsequent intergranular melting, was readily visible in the near surface microstructure. A liquid eutectic mixture containing primarily iron, oxygen, and sulfur formed during this hot attack on the steel. They wrote an article. It's called Worcester Polytech WPI Transformation, Spring 2002, The Deep Mystery of Melted Steel. This Swiss cheese appearance shocked all the Firewise professors who expected to see distortion and bending, but not holes. And the New York Times wrote a report on it. They called it the deepest mystery that was uncovered. They call that perhaps the deepest mystery uncovered in the investigation. Okay, again, because you would not get melted steel, and it was melted steel. Well, let's back up a little bit. What's a eutectic, first of all? Let me explain what a eutectic is. Okay, a eutectic is a mixture of two substances, could be more than two substances, that melts or freezes, melting point and freezing point's the same number, right? At a single temperature that is lower than the melting or freezing point of either substance. That single temperature is known as the eutectic temperature. Okay, well, what's that mean in our real world? Well, most of us drive cars or we've been in vehicles. Water, we know, melts at or freezes at 32 degrees, okay, or 0 degrees Celsius, same thing. Ethylene glycol, if you go to the auto parts store and you buy antifreeze, pure ethylene glycol, and you take a cup of that and you put it in a deep freezer, well, that'll freeze too. That'll freeze around 10 degrees Fahrenheit or minus 12 degrees Celsius. Okay, so water at 32, pure antifreeze at 10 degrees. But if you mix those two together, okay, if you mix like a 50-50 mix of those two, it'll actually lower the freezing point below either one of those things. So here's a little graph here. If you go to the 50% mixture of antifreeze, here's antifreeze, well, it'll drop it down to about minus 40 degrees Fahrenheit, which, by the way, is the same as minus 40 degrees Celsius, same thing. It's just a conversion the way it works out there. So really, pure antifreeze, if you're going to get your car ready for this winter, you don't want to put pure antifreeze in it. You want to put a mix in because it'll actually protect it to a lower temperature. So this is an example of a eutectic. Well, the FEMA report, again, they said severe corrosion and subsequent erosion of the samples are a very unusual event. No clear explanation for the source of the sulfur has been identified. So the key was there was sulfur in it, okay? And Dr. Greening, professor, put together a report. He wrote a paper called Sulfur and the World Trade Center Disaster. He wrote it in May of 2006. And he was trying to find rational explanations for where that sulfur could have come from in an ordinary building. Well, he came up with the idea, well, maybe it was in the gypsum wallboard. There's a little bit of sulfur in diesel fuel. Maybe it came from there. And he said, well, maybe some molten aluminum reactions with gypsum wallboard. Maybe that was a source of the sulfur. Well, NIST, in one of their FAQs, they say, is it possible that Thermate or Thermite contributed to the collapse of World Trade Center 7? We're going to get to that later. But they said that the analysis of the World Trade Center steel for the elements in Thermate would not necessarily have been conclusive. Okay, that's not the key point here. Then they say the metal compounds would also have been present in construction materials making up the World Trade Center buildings, and sulfur is present in the gypsum wallboard used for interior partitions. Okay, now here's some clever wording. They say sulfur is present in the gypsum wallboard. They didn't say that gypsum wallboard would attack that steel and cause that intergranular melting, but that was the implication. So the mainstream explanation to help put aside this big problem that they were having was that the source of the sulfur was from normal building materials found in the rubble. The BBC jumped on this, and the BBC explained it to the rest of us that watched their programs. Here's what they said.
Despite the collapse of Tower 7 making architectural history as the first skyscraper to collapse because of fire, all the steel from the 47-story skyscraper was taken away to be melted down. Some made its way into this new US Navy vessel. But it turns out one section of steel was kept. How it got to be in its present state was described by the New York Times as perhaps the deepest mystery uncovered in the investigation.
There's parts where the entire half-inch of the beam is gone, entirely dissolved right through, and so something happened to cause the steel to really thin and in some places to disappear entirely.
In New England, the claims of the mysterious melted steel from Tower 7 has been unraveled. It was found by fire protection engineer Professor Jonathan Bonnet in a salvage yard.
It came from a much larger beam. This was the size of steel that they used in the construction of Tower 7. They didn't use this particular kind of steel in Towers 1 or Towers 2. So that's why we know its pedigree. It was a surprise to me because it was so eroded and deformed. And so we took it for analysis in the lab.
Well, it was attacked by what we determined was a liquid slag. When we did the analysis, we actually identified it as a liquid containing iron, sulfur, and oxygen. You can see what it does is it attacks the grain boundaries, and then this bit would eventually have fallen out, and it would continue the attack.
Professor Sisson says it didn't melt, it eroded. The cause were those very hot fires and the debris after 9/11 that cooked the steel over weeks. The sulfur came from masses of gypsum wallboard that was pulverized and burnt in the fires.
I don't find it very mysterious at all that if I have steel in this sort of a high temperature atmosphere that's rich in oxygen and sulfur, this would be the kind of result I would expect.
So again, what he said was, if it was in the presence of sulfur, that would be the result he would expect. The problem is what the source of the sulfur wasn't what would happen if sulfur would be on it. Now, there's sulfur, and there's different variations of sulfur, I suppose. I don't know if they're called variation, but sulfur is a non-metallic element. It is an element, okay? But there's also what's called sulfite and sulfate, okay? And those are not elements, and those are what, they didn't say it was attacked by sulfate. In gypsum wallboard, is CaSO4 has it in it. That's called calcium sulfate, not sulfur. Okay. More importantly, gypsum, if you're in any part of the building industry, and you're probably sitting in a building right now that has gypsum wallboard around you, gypsum is used to protect steel, okay? A lot of times we have what's called tenant separation or different fire ratings of steel. We have steel studs or steel systems. What do? We add thicknesses of gypsum wallboard. Well, because it's there to protect the steel, it certainly wouldn't attack the steel. So something didn't make sense on its surface. Now, there was an alternate independent theory that came out trying to figure out where the sulfur came from, okay? Stephen Jones, Kevin Ryan, and some other authors put together extremely high temperatures during the World Trade Center destruction, and they suggested that various incendiaries, including thermate, were the contributing cause of the intergranular melting. Well, everybody wanted this thing solved. The FEMA report, they said a detailed study into the mechanism of this phenomenon is needed to determine what risk, if any, is present to existing steel structures exposed to severe and long-burning fires. So it was an important issue because we have drywall everywhere. The debunkers, the people who were supporting the official story, they also wanted it solved. They said, at the time of this writing, NIST has not yet issued its report on World Trade Center 7. It may and should address this issue in their final report. NIST said they would address it. NIST said they would address all major recommendations contained in the FEMA report. Scientists supporting the official story wanted an experiment. Remember Dr. Greening? He said, by way of verifying these conclusions, drywall and diesel, it suggested that NIST fire tests should be repeated using a more realistic environments that include shredded aluminum alloy, crushed concrete, and gypsum, water, rusted steel, aviation fuel, plastics, etc. So he wanted an experiment. He knew how important experiments were. Now, even scientists supporting the alternate hypothesis, the thermate hypothesis, they also want an experiment. NIST should do an easy experiment in the presence of gypsum and then test whether sulfur has entered the steel from the gypsum. Well, NIST, once again, they dismissed the relevance of the eutectic steel. Well, they said it because this steel was clearly in the prone position during the corrosive attack and was located no higher than the 53rd floor of the building, the tower. This degradation phenomenon has no bearing on the weakening of the steel structure or collapse of the building. So they just ignored that evidence. They didn't want to deal with it. And they also refused to conduct an experiment, even though everyone on both sides wanted them to conduct an experiment to solve this deep mystery. Well, they never did. So I thought it was time we conduct our own experiment to solve this deepest of mystery. So what I did is I got a steel beam. This is probably 12 years ago now. I got an ordinary wide flange beam, and I took gypsum drywall, fuel, water, aluminum, steel, crushed concrete, everything that was suggested in those reports, and I packed it around this steel beam. Okay, this was just the initial setup. Well, then I built this test beam, and in order to hold it all together, I had to take some wire and lath. Here's some regular fence wire, and here's all this gypsum packed into it, and in between is all the crushed material that they suggested we use. I had a pretty good sized burn pile. I had a lot of organic material that I wanted to get rid of. And so I built this burn pile and I set this beam on this pile. And then I lit it up and I let this thing burn all day long. And I took my front end loader and I just kept dumping more and more and more material on it. So it was a nice hot fire. Well, it burned all day. It burned all night. Here's that beam in there. Here's this little mesh. You can see it didn't melt. You can see how red this stuff got. It got red, but notice the steel never melted because this fire is too cold to melt steel, just like an office fire. Well, I let it smolder for a while, let it cool down. Here's some of that drywall. with my mockingbird in the background. And then I pulled it out, used my loader, lifted it up. I did have some lift holes here, if you saw those holes there. I lifted it out for inspection, then cleaned everything all off. And lo and behold, would we find? Well, it was perfectly solid. There were no holes like Swiss cheese or any intragranular melting that was observed after this experiment. This is nature telling us that gypsum theory is wrong. Now, to his credit, Dr. Greening did send an email. And again, I give him credit for this. He said, I am prepared to admit that my initial proposal of how the steel was sulfided during the 9/11 events needs to be modified. Certainly, it looks like diesel fuel, gypsum, concrete, and aluminum alone are not going to do it. So the conclusion, based on experiment, we're using Richard Feynman's recommendation to do an experiment, was that, well, since the claim that the sulfur source was drywall disagrees with experiment, all the mainstream experts, the BBC, NIST, they're all wrong. There had to be some other source of the sulfur that was caused the most unusual event. It was still a deep mystery. Question is, what was the source of that sulfur? It wasn't gypsum. Well, then I got into some thermate experiments. Okay, well, if it wasn't gypsum, the other folks were saying, well, maybe it was thermate. So I put together a video called The Great Thermate Debate. Well, what's thermite, first of all? Okay, I'd never heard of it either, so don't feel bad. Well, thermite was discovered in the late 1800s by a German chemist. It's basically iron oxide and aluminum, and when it reacts, it produces iron and aluminum oxide. This is the chemical equation for it, and this is what it really means. Iron oxide and aluminum, it reacts, forms iron and aluminum oxide. Well, what that also means is basically you take some rust and you take some aluminum, ground up aluminum, it'll create heat, lots of heat, like over 4,000 degrees heat. It'll also create iron spheres. It'll make lots of white smoke, okay? This right here, this 2Fe, that's elemental iron, okay? That's those iron spheres. Well, okay, that sounds good. Let's prove it. Now, thermate is a variant of thermite, okay? Thermate contains sulfur. So all those chemicals I mentioned before, the iron oxide and the aluminum, well, if you add sulfur to it, it's just a different name for it. It's called thermate, okay? And according to Wikipedia, you can look this up, sulfur generates a eutectic system when molten thermite interacts with iron or steel, lowering the melting point of iron. Remember that interaction graph we did with water and antifreeze? Well, the same thing. When you add sulfur to thermite and make thermate, it will lower the melting temperature. Well, a lot of questions were being asked. Scientists like Kevin Ryan, he's a chemist. He worked at Underwriter Laboratories. And Professor Stephen Jones, who we're going to hear more from later on, he was a professor at Brigham Young University. They were asking an awful lot of good questions about how the extremely high temperatures and the possibility of a thermitic material was being used in the tower's destruction. And it was kind of coming out pretty hot and heavy in 2006, 2007 timeframe before I even got involved in this thing. So something had to be done. So the establishment, there was kind of a backlash to all that questioning that was going on. So Kevin Ryan, he got fired by UL in 2004. Stephen Jones was placed on leave by BYU, and he kind of took an early retirement, so he was asked to leave. There was a paper that was put together later on. It was called The Active Thermitic Material Discovered in the Dust. That was published in what's called the Bentham Open Civil Engineering Journal. Well, that editor was kind of asked to resign, or did resign. And the mainstream media, that's where we get our information from. The mainstream media, they stepped up to convince you that thermite, that demolition theory, well, that had no validity. Now, there was a lot of questions. Remember the show Mythbusters? Well, everybody wanted them to do experiments. Well, they got so much heat on this thing. They said the events of 9/11 will not be allowed to be debated or discussed. And they did a little show about thermite, and they could hardly melt through the car roof with a 1,000 pounds or a half a ton of thermite. This is just a very short clip of that little experiment.
Like I was hoping, there's not going to be a whole lot left of that car.
But rending the roof wasn't the main aim. They just want to know one thing.
Was this better than a bang?
Okay, so there's a little thin roof car. They put a half a ton on there. It barely went through that, and that roof is pretty thin. Well, then the National Geographic, they stepped up to the plate, and they had some explosive experts, and they put together a pretty extensive video, and they proved that 175 pounds of thermite could not have melted a steel column. And they kind of made this statement, well, if thermite melts through this steel column, the theory of a thermite-controlled demolition may have some validity. And they asked the question, well, can thermite of any type? Okay, now remember Professor Jones was mentioning a different type of thermite, but they're saying, well, any type of thermite, can it melt through steel beams? Let's listen to what they did and let's look at their experiment.
Thermite melts through this steel column. The theory of a thermite-controlled demolition may have some validity. While the truthers insist that more explosive super thermite could have been used in the tower demolitions, testing conventional thermite can illuminate this physical process and answer a simple question. Can thermite of any type burn through steel beams?
The lining of clay wasn't a total success. We can see where the clay broke off, but it looks like most of the material just basically boiled out, and we did not get that heating action that we wanted on the column.
Despite 175 pounds of thermite packed around the steel column, it remained undamaged.
So they were showing you that, look at these guys are saying thermite or thermate was used. There's no way it could have been used because we can't even get through one single column. Now, the debunking sites, they also said, the debunkers are the people who support the official stories. They also had some sites. They also said that it could not cut a vertical column. And they said, well, the thermite would have also needed to cut sideways. Not an easy feat for thermite. You see, it's a powder which burns chaotically. Maybe with some device, but no working device has been proven to be to work or cut a vertical column. So we were led to believe that thermite cannot melt steel. It can't cut steel horizontally or vertically. And it would take an awful lot of it, a massive amount, to do any real damage. Well, I thought about this and I thought, well, let's run some of our own experiments and let's see if we come up with the same answer. So I put together what's called Thermate. Okay, and when you can buy this stuff, these are the 4 elements that I use, and there's different variations of thermate, but one of the main things is that sulfur right there, and it should be put together in what's called a stoichiometric ratio, and what that means, it's just the right amount of each material where the reaction proceeds to completion without any waste or everything's consumed and there's no deficiency or no excess. So it's the most efficient way to put it together. So I took this stuff and put it in a bucket and just started mixing together, and it's just a mix of powder. Now, thermate is very difficult to ignite. I tried to use ordinary underwater fuse because that's what I used to use as a kid, blowing up stone walls and things. So I used ordinary fuse. Well, that didn't work. That's the first thing I learned. But once you do ignite this stuff, and then I finally started using a magnesium strip, that would do it. Well, it makes a lot of heat and a lot of white smoke. And it also makes a lot of small spheres of iron. Well, those iron spheres are a natural byproduct of the reaction itself. I used a magnet to pick it up, and here it is, these little round spheres of iron. Well, my first try, I had thought that, well, you know, the National Geographic folks, they just had it in an open container. I thought, well, if we press it against a beam and hold it against it, surely that'll melt that connection there. And so what I did is I took some old roofing tile and I wrapped 5 pounds of thermate into that tile with some saran wrap, and I put it on both sides and I tried to hold it in with magnets. The question was, how can you hold a tile against a beam? Any of you farmers out there might recognize this is a hay rake spring tooth or a baler spring tooth, and I just use that to press it against there. Let's see what happens on my first experiment. Yeah, well, nothing happened. Guess what? It was just like the National Geographic experts. Nothing happened. It kind of blew this away from my hay rake spring tooth, but nothing happened. So I kind of scratched my head for a while. And like I say, if at first you don't succeed, stop, swear, and then proceed, which is pretty much what I did. So I decided to build what I call my thermitic box cutter. I took some ordinary box tubing and I had a slot milled in the side of it. Well, here I'll let this tell the story.
But the steel did not melt, meaning that perhaps a container could be made out of steel after all. Using an ordinary steel box tube, I had a slot milled along one edge. Welding the bottom and using clamps on the top to hold the powdered thermate in, I bolted it to a steel beam vertically. I called this device my thermitic box cutter. With only 1.5 pounds of thermate, or less than 1/100th of what the National Geographic experts used for their experiment, not only was I able to melt steel, but it also sliced a vertical cut. So I made a slightly larger thermitic box cutter and used 2 3/8 bolts drilled and tapped on one side of the connection. It only took a slight twist to break it completely off. I noticed as the thermate burned, it tended to lose its cutting power, perhaps because it could expand into the area where the box cutter previously burned. So I built a piston-driven box cutter using a compressed car hatch piston. I added sheets of tungsten to minimize the burnout and allow the piston to slide better. I then bolted my contraption to the flange of the column and ignited the white-hot magnesium. It appears that not only can thermate melt steel, but it can also cut vertical columns.
Yeah, and that piston device I sort of invented. Unfortunately, that got jammed. It couldn't go all the way through, so I only burned through most of it here, not all of it. All right, so it looks like looks like it can start to do some damage. Now, notice the spray in this experiment here. I'm going to play this. Notice the spray that comes out of a thermitic reaction. And imagine if your car was parked next to it. I didn't want to park my car next to it, but imagine if you parked your car next to it. What do you think would happen for the paint job of your car? Take a look at this. Now, if your car was parked under that, what would you expect? Would you expect the top part of your car to have some problems with the paint? Now, that was molten coming off of there, but those iron microspheres, after they cool just a little bit, if they're falling down, they will cool, but they'll still be super hot. They may not be 2,800 degrees. They may be 1,000 degrees, and at that point, they'll no longer glow, so you might not see it. Well, there was a huge flow of white smoke and debris in ground zero. Okay, and there was talk of toasted cars. Now, the directed energy folks are saying that, wow, these cars probably got toasted from some faraway space beam or directed energy by the government, and they toasted all the top of these cars, and they couldn't explain how these cars could have got toasted. Well, if these were parked near the towers in this heated flow, is it possible that maybe some sort of thermitic reaction, or maybe some of this stuff was burned by the falling hot material? Doesn't that sound like a simpler answer than some sort of faraway directed energy weapons? Now, I want you to notice something else here. I want you to notice the molten metal. Okay, let's look at that experiment I did where I sliced this beam connection here. Just take a look at the molten metal that comes out. You'll see it pouring out here near the end of the experiment. You see it right here? You see it flowing out of there? What color is that? It's yellow, right? It's not silver. All right, let's compare that. Here's a screen grab of that. What color is this and what color is this? They're about the same, aren't they? Do they look similar? Now, I know mine was not silverish, and I also know I wasn't using aluminum. Those were steel beams, and I was using thermate. There was no aluminum involved, and the colors are quite similar. Now, another frequently asked question was, did investigators consider the possibility of an explosion called or contributed to the collapse of World Trade Center 7? Well, in their answer, NIST said, yes, this possibility was investigated carefully. They looked at this very carefully, and they concluded that blast events inside the building did not occur and found no evidence supporting the existence of a blast event. In addition, no blast sounds were heard on the audio tracks or of video recordings during the collapse of World Trade Center 7 or reported by witnesses. Again, you got to read this carefully. They're saying they didn't hear anything during the actual collapse of World Trade Center 7 or reported by witnesses. Well, what about just before it collapsed? Was there anybody or any audio recording of any kind of explosive sounds?
Yeah, here's one of the guys who can tell you I'm okay, all right? Here, hold on. You want to call your mother or something?
Right now.
All right. Don't worry.
Well, they ignored that. Another frequently asked question is, did investigators consider, it's the same question, a possibility that an explosion caused or contributed to the collapse of World Trade Center 7? Another excerpt, according to calculations by the investigation team, the smallest blast capable of falling the building's critical column would have resulted in a sound level of 130 to 140 decibels at a distance of at least a half a mile. Now, what are they assuming here? Some of you are familiar with the World Trade Center 7 collapse. They're saying that just one column, what's called column 79, in order to take that one column out, which triggered the entire collapse, according to NIST, you would need a blast of 140 decibels. Again, so their assumptions was that the blast was placed on one critical column to bring it down. And again, that went down at free fall acceleration. Well, why couldn't, when you do a controlled demolition, don't they put them on multiple columns? Just like the University of Alaska Fairbanks study suggested? They didn't just put it on one column, they put it on all columns. And did it really have to be 130 to 140 decibels? What about a quieter thermate charge? Is that possible? Well, here's a patent. This apparatus and method typically provides for a reaction that provides cutting action in a non-explosive manner. Non-explosive manner is defined as a reaction that proceeds below the speed of sound in the reacting material. By proceeding below the speed of sound in the reacting material, a shock wave is experienced and explosives is avoided, so you wouldn't hear it. Well, it is true that thermate can be pretty loud. I learned that myself. This is a thermate reaction. So thermate is supposed to be an incendiary. That just sounded pretty loud to me. But it depends on how it's configured. I learned that if I configured this stuff differently, I would get different audio results. It can also be kind of quiet, a little bit of a pop, then kind of burn quietly, and then just pop. Notice the white smoke, lots of white smoke. Now it can also be quiet. Okay, here I light one off, and actually there's hardly any noise at all. I'm not going to say no noise, but hardly any noise at all. So it can also burn quietly. Again, it depends how it's configured. So we have a range of what the audio is on when we play with thermite or thermate. Now, NIST, the other words that they didn't want to use besides melted steel, the other one was explosions. They didn't want to use the word explosions. No melted steel and no explosions. What they did is they used other words. They used what's called pressure pulses and dust puffs. And we have some going off here on the side here. So, for example, they said, well, these included repeated pressure pulses that push smoke and or dust, in some cases flames, from multiple open windows. Okay, the sources of the pressure pulses that created the wide spread of smoke and or dust puffs observed on multiple faces of World Trade Center 2 are unknown. Relatively small amounts of molten material, don't want to say molten steel, poured from the window of 80 to 255 near the start of the end of a series of pressure pulses. Not explosions, pressure pulses. Well, can thermate make pressure pulses and or dust puffs? Well, let's find out.
Rather than using a mechanical piston to maintain volume, I segmented my box cutter with steel plates, hoping to get a more uniform burn, but got some unexpected results. Can thermate make pressure pulses and or dust puffs? I guess it can. But why waste all that thermate and energy cutting the columns? Why not attack the weakest areas instead? Can thermate cut bolts? I guess it can. But what if just the head of the bolt is exposed rather than the nut and the threads? Can thermate be configured to cut just the bolt head? I guess it can. And without any evidence on the other side. I don't think that something like my piston-driven box cutter was bolted to the office walls, or trash bags full of thermite used. It's more likely that any pre-weakening thermitic material were hidden inside the perimeter box columns. I had a replica of a segment of the WTC box columns made up. And like the Trade Center iron workers, I bolted the segments together and made 2 sets of my 2 bolt blasters, placing them in the access hole. Let's listen to another eyewitness.
Like, it sounded like gunfire, you know, bang, 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 and then all of a sudden, 3 big explosions.
Is it even possible that thermate could do this? I guess it is. I made a 4-sided internal box cutter that was split into 2 pieces so they could be inserted inside the column. Let's see what happens. I think my box cutter blew about 50 feet up, consuming valuable energy and trimming my trees in the process. Nevertheless, the inside of the column was cut about 3/4 of the way through. Were thermitic devices or maybe explosive nano-thermite sprayed inside those box columns? I'm not sure.
And I'm not sure. I'm just showing what thermite can and can't do, contrary to what we were told by the National Geographic experts. Remember, they said, can thermite of any type burn through steel beams? They implied that it could not. Now, had I known that those were simply dust puffs, kind of something you look like under your bed, I guess, when you're cleaning under your bed, and or pressure pulses, maybe I wouldn't have run so fast from this experiment. Actually, I'm kind of glad I did. I've done a lot of stupid things in life, and that might be one of the top ones. What about that eutectic steel? Can thermate make holes like Swiss cheese? Well, I made a different setup for this. I had a little vertical column here, and I made a setup where I would put thermate on both sides of this. And then these were magnesium strips. I would light these and just to see if I could get the same look as they did with that eutectic steel. So here's the setup. Here's the web attack, the little experiment I did. And here's the after effect. Oh, by the way, it can also be set up on a column. They said it couldn't be done on a vertical column. So I did the same setup. I did it on a vertical column also. Now, after the attack, here's these things glowing red still. Looks like we have some stuff in there. Looks like there's some holes in what wasn't there before. The web was reduced in thickness with gaping holes, thin to almost razor sharpness, with a Swiss cheese appearance. So here I am peeling my carrot, and it looks like thermate, just as Professor Jones suggested, would make gaping holes, kind of like that eutectic steel. Now, again, it depends how things can be configured. It turns out, and this isn't what I'm suggesting happened in the Twin Towers at all, but it turns out that you can configure thermate to be used as a propellant. I didn't mean to do this, but here we have, here's one of my experiments, and it kind of launched up in the air. Somebody can calculate out how that went. I think it went about 50 feet. And like I said, I didn't mean for it to happen, but like I said, it really depends on how you configure things, on how nature will make things react. Now, there's also, I was just using ordinary thermate or thermite. There's also, in addition to those iron microspheres, independent scientists also found what's called nano-thermite. Okay, let's listen to Professor Stephen Jones. He's the one that found this, along with some others.
What's really important then is what's in the dust, because that tells us what happened during the collapse. Early on, I saw these chips, red chips, and so several months ago, I decided we ought to take a closer look, and it was quite remarkable. We're still studying that, and now in at least 3 different laboratories studying these red chips. They do have the chemical composition of thermite. We use a magnet to extract the iron-rich fraction, and that's where we see these red chips in abundance. They're rich in iron, and also the spheres, iron, aluminum, oxygen spheres, very common in the dust.
Okay, so he found some very unusual things in the dust. Now, there was peer-reviewed papers that were put together over the years showing those extremely high temperatures. Again, you would not get that in an office or a jet fuel fire. And there was a peer-reviewed paper, as I mentioned early on, called Active Thermitic Material Discovered in the Dust from the World Trade Center catastrophe. And that was put together with a bunch of top scientists from around the world, really, that looked at this stuff and look at these. These are some photographs of these matrices of the particles that are in it. And so that really raised some questions too. And of course, the official stories, they wanted to ignore that. And by the way, so everybody was kind of jumping on the bandwagon. So, well, that must have been primer paint. Well, it wasn't primer paint. Matter of fact, I looked at it. Here's a setup I did back in my office 10 years ago or so. And I looked at primer paint. This is nano-thermite. This is primer paint. So it wasn't primer paint they found, not only because it doesn't look like it, but primer paint doesn't ignite at the low temperature that these chips ignite. And when you ignite these chips, they produce little iron microspheres. Well, primer paint doesn't do that. And again, it doesn't even look like it, but that's the common response. Oh, it must have just been paint. It wasn't paint. Now, unlike ordinary thermite, okay, which is again considered an incendiary, nanothermite is a powerful explosive. Well, how do we know that? Well, it's all written up in the papers. Nanoscale chemistry yields better explosives. We have developed a new method of making nanostructured energetic materials, specifically explosives, using sol gel chemistry, says Lawrence Livermore Laboratory. All of the military services and some DOE and academic laboratories have activated R&D programs aimed at exploiting the unique properties of nanomaterials that have a potential to be used in energetic formulations for advanced explosives. And properties include energy output that is twice that high of explosives. A new class of weaponry that uses energy-packed nanometals to create powerful compact bombs, and building more lethal weapons such as cave-busting bombs that have several times the detonation force of conventional bombs. And finally, nano-sized thermitic materials are being researched by the US military with the aim of developing new types of bombs that are several times more powerful than conventional explosives, so says Wikipedia. Now, nanothermite is completely different. My thermate was a mix of kind of large size powder, okay, with particles kind of comparable with elephants versus nanothermate like ants. It's kind of like salt and pepper being mixed together versus cream and coffee being mixed together. The particles are very, very small. Kevin Ryan, again, he's a chemist. He actually used the formulation from Lawrence Livermore Labs. He actually did it. Here's a synopsis of the experiment that he did. He mixes these together, and they're just 2 liquids. That's how fine the particles are in this. Okay, and then he heats it, relatively low temperature, and just a very, very small amount of it. Watch what happens. It's explosive. That's a very small amount of homemade nanothermite that Kevin put together. Paint won't do that. Primer paint will not do that. Now also, another experiment was shown on mainstream TV, and this is by Dr. Van Romero. Jesse Ventura had a TV show, and he explained that actually this stuff can be painted on steel, according to him.
Hello, Governor. My name is Van Romero, and I understand you have some questions about superthermite. Well, let's do an experiment. The first step in the experiment is to make the liquid superthermite. We mix it in with the paint, And then we have our super thermite liquid paint. Once we make the mixture in the lab, we take it out into the field to do the test. Before we apply super thermite to a beam, let's take a beam without super thermite on it and subject it to a fire. 3, 2, 1, fire. As you can see, fire burns and the beam slowly heats up.
The beam burns briefly, but it does not melt.
Now let's paint the super thermite onto the metal beam, subject it to a fire, see what happens. Fire! As we expected, the beam with the thermite is burning much brighter. It's a much hotter fire than we had before. So the temperature is going to rise in this beam more than it would in the beam without the thermite. Does it burn long enough and hot enough so that we have structural failure?
All right. Anybody still got any doubt?
Now, I don't know how else it can be applied. Maybe it's a spray foam. I don't know. I don't know how it can be applied. But according to him, it can be painted on steel. But once again, the BBC, even after I did my experiments, they had to come up and they had to once again prove that thermite cannot melt steel. So they put a program together. I think it was called Conspiracy Road Trip. And this was done after I did my experiments to again prove that it can't melt steel. And also they say that the paint would actually slow down the reaction, possibly prevent the reaction from occurring. So contrary to what we were just told by Dr. Romero.
Charlotte and Rodney now want to convince us that the Twin Towers were brought down by a controlled demolition using thermite packed around the girders. So I found them a real buffin, a thermite expert from the University of California, and I've sent them off to conduct a DIY chemistry experiment.
It's not really an explosive. It's more of just an incendiary.
Yeah, it creates a lot of heat.
Yes.
Yeah.
Yeah, but it will demonstrate how it can be how steel can be melted.
It's a simple recipe, mixing very small particles in a powder that creates an intense heat when it burns.
Look at that. Very, very similar. Red grey chips.
Just be prepared to put a safe distance between you and the reaction.
Charlotte and Rodney are sure that when this mixture is ignited, it will cut through a steel beam.
Woo! Oh my god! Oh, it's so hot! Oh wow!
So it's aluminum oxide and iron metal. They've partially separated based on their densities.
They can strip into the floor.
Yes.
Unfortunately for them, it's clear that 3 kilos of thermite has barely affected the steel beam at all.
It seems that you need like a big bucket of this stuff to burn through that beam.
Yes, you need a lot. Probably hundreds of pounds. It seems very unlikely that so much thermite could be strategically placed like this.
Is it possible to put this stuff in paint and then paint it on?
In fact, it would act to slow it down or possibly prevent the chemical reaction from occurring.
Would the fire have acted to ignite the thermite reaction?
Well, it's very difficult to ignite thermite. We have to use magnesium ribbon here, and it's very hard.
Thank you very much. It's becoming more and more unlikely that this stuff was used to bring down the buildings.
All right. So again, he used 3 kilos and it didn't do anything. I used a lot less than that and I could cut through a steel. It depends on how it's configured. That's the key to this thing. Now, what about the fires in Ground Zero? Ground Zero was flooded with thousands of gallons of water and yet it burned for months. Well, can thermite burn underwater? Again, this is from the Backyard Scientist. This does not mean he endorses this video, but this is just what nature is showing us.
If you've never seen it before, thermite is a mixture of finely powdered rust and aluminum. It burns at over 4,000 degrees and produces molten iron. You need a small strip of magnesium to ignite it, and once it gets started, there is no way to stop it. Not even water can quench the fire put out by thermite.
Okay, so it makes its own oxygen. Water can't put it out. Now, NIST talks about the melting of steel in ground zero. Now, remember, ground zero, the towers were mostly made of steel and concrete and not office furniture. And in the basements of that was mostly the parking area. But NIST says that they're starting to give a little bit and they say, well, under certain circumstances, it's conceivable that some of the steel in the wreckage to have melted after the buildings collapsed. Any molten steel in the wreckage was more likely due to the high temperature resulting from a long exposure to combustion within the pile than to short exposure of fires or explosions while the buildings were standing. So they're saying, well, it got all hot down there because all the material was down there. Well, just a real quick side note here, a little science thing. Heat is not temperature, okay? Heat is the quantity of thermal energy that enters or leaves a body. It's dependent upon the quantity of material, okay? And it's measured in joules or calories or BTUs. Temperature is nothing more than the measurement of the average energy of the average molecule in a body. It is independent of quantity, okay? You can have a campfire versus a forest fire. The temperature is the same, the heat's different. Or if you double the logs in a burning stove, the heat may double, but the temperature won't. It'll stay in the same temperature no matter how much wood is added. The temperature won't change. So it doesn't matter if it's in ground zero or not. You're not going to get any more higher temperatures. So should ground zero get hotter or colder if it was a normal office fire? Well, there's different kinds of fire. There's premixed flame, there's jet burners, and there's a diffuse fire. A diffuse fire, it's where the air is not mixed before combustion and is nowhere near as hot. The Twin Tower fires were diffuse. A smoldering fire has less air and burns colder. According to Wikipedia, the characteristic temperature and heat released during the smoldering are low compared to those in a flaming combustion. So if the fires in ground zero was from a normal office fire, the temperature would not increase no matter how much office furniture was in the basements. The temperatures would be lower, not higher than when in open air. The temperature from an office building is still too cold, regardless of how much is there, and impossible still to melt steel. Remember that steel there? It doesn't matter how much you add to it. It's not going to melt. And if it couldn't be put out with water, and there was melted steel, a lot of testimony of melted steel, then ground zero was not a normal office fire. Now, one last thing, in addition to producing the round spheres and the white smoke, Nano-thermite also produces carbon nanotubes. Kevin Ryan and Professor Niels Harriet proved it when they did an experiment. Now, carbon nanotubes is a tube made of carbon with diameters typically measured in nanometers. Carbon nanotube, CNT, requires three basic components: a very high temperature, a source of the carbon, and the presence of certain metals. All three requirements are met in the ignition of nanothermite. Kevin Ryan and Professor Harriet did it. Well, so what? Well, right after 9/11, thousands of people rushed down there, and they were told by the Environmental Protection Agency the levels of lead, asbestos, and volatile organic compounds in the air samples taken Tuesday in Brooklyn downwind from the World Trade Center site were not detectable nor a concern. Given the scope of the tragedy from last week, I am glad to reassure the people of New York and Washington, D.C. that their air is safe to breathe and water is safe to drink. Now, this was from the EPA, but they got all their orders from the National Security Council. There was an internal memo that says all statements to the media should be cleared through the NSC before they're released. And the New York Post reported that the National Security Advisor, Condoleezza Rice, was the final decision maker regarding release of information by the EPA. I mean, who knows more about science and air quality than the National Security Council? Certainly not the EPA. So they were dictated what to say in defense of the EPA, but they said that the air was safe. Now, thousands of volunteers rushed down there to help. And a study by Mount Sinai Hospital found that 7 of 10 World Trade Center rescue and wreckage workers had new or worsened lung problems after the attack. This was done in 2006. The New York City Health Department has a database of 71,000 people exposed to dust and debris at ground zero, a database created in response to the hundreds of people's complaints of breathing and lung problems. Okay, then in 2010, researchers at Mount Sinai School of Medicine reported the presence of high levels of carbon nanotubes in the lungs of the World Trade Center first responders, as well as in the dust samples. They tested the dust and the first responders, and they both found carbon nanotubes. The finding of carbon nanotubes in both the World Trade Center dust and the lung tissue is unexpected and requires further study. And this is their report they put together. You can find that case report. So it was very unusual, never seen before with construction workers. So let's jump real quick to the theory comparison. Remember those 7 theories? Well, we have the molten metal, the cut core ends. We have the iron microspheres, the source of the sulfur, the razor sharpness, why water couldn't put out those fires, the nanothermite that was found in the dust, the white smoke, the explosions, and then the carbon nanotubes. None of those theories can address these. Only explosive and incendiaries bringing down those towers can address all of them. Now, most believe the pseudoscience are told by the media. That's where we get our information from. But some people know better. Okay? Do you really think that these guys right here believe the BBC or the National Geographic nonsense that thermite can't melt a steel beam when their job is to melt railroad track together and weld it together using the same material, thermite? They know better than that. Well, what can we conclude with all this? Okay, if we use a scientific method rather than just listen to the establishment pseudoscience, well, the yellow-orange metal pouring from the Tower 2 is not molten aluminum. It can't be. Nor is it a mix of partially burned office furniture and molten aluminum. It can't be true because they don't mix. The Eutectic steel found by the Firewise professors was not caused by massive amount of gypsum that stewed in a pile for weeks. There must have been some other source of sulfur. There's overwhelming evidence of melted steel. Jet fuel in office fires can't melt steel beams. Thermite can melt steel beams. Sulfur generates a eutectic mixture when molten thermite interacts with iron or steel, lowering the melting point of iron, according to Wikipedia. The natural byproduct of the thermitic reaction includes iron microspheres and white smoke that we saw in Ground Zero. Thermite can cause holes like Swiss cheese, like those found in the FEMA report. Thermite can cause razor-sharp edges, like those found in the FEMA report. Thermite can react underwater, like the fires at Ground Zero. Thermite can make pressure pulses and or dust puffs, as described in the NIST report. Nanothermite was found in the dust and reported in a peer-reviewed study. Nanothermite's a powerful explosive, according to the U.S. Department of Defense. Nanothermite can be painted on steel, as demonstrated by Dr. Van Romero. Nanothermite was made in military labs, like the Lawrence Livermore Labs. A byproduct of nanothermite is carbon nanotubes based on experiment by Kevin Ryan. Carbon nanotubes were found in the dust of many of the volunteers and workers at Ground Zero, according to the case study by the Mount Sinai School of Medicine. Now, there's lots of things I don't know. I don't know where the thermitics were placed. I don't know when it was placed. I don't know who did it, and I don't know how many were involved or what their names are. But I do know they make linear thermite cutting charges, and that explosive nanothermite chips were found in the dust. And thermitic reactions explain so much of the evidence found. And even though the media experts told us that thermite can't melt steel, now, and I hope you know, that the answer to this question.
Can thermite of any type burn through steel beams?
I think we know the answer now, despite what the National Geographic was telling us. Now, if you want information, additional information and resources on this, if you find this kind of an interesting topic, do some research. I would recommend ae911truth.org. If you think this is a problem, maybe consider signing their petition. You don't have to be an engineer. You can sign their petition and think that something's wrong here. And all their petition is saying is that we think there's something wrong and a new investigation should be made. They also always need donations. Like any organization, they always need money. Another good site, I talked about the NFPA codes there, is firefightersfor911truth.org. If you want to see the entire experiments that I put together, I have a YouTube site called Physics and Reason, one word. If you don't put it in exactly, you will not find me. And it's on what's called 911speakout.org. There's other scientists and physicists on that. A lot of good information on that site. If you want to know more about the nanothermite, Kevin Ryan has got a site called digwithin.net. He talks about those carbon nanotubes in the World Trade Center dust. And he also talks about the top 10 connections between NIST and nanothermite. There's a lot of information on Kevin Ryan's site. He's a main researcher on this topic. So they told us to never forget, and they want us to forget now. They don't want to know the information I'm sharing with you, but don't forget what they told us. They told us to never forget. And this information is awkward, especially if you've never seen this before. It upsets your very world view. But in my opinion, like Kate Chopin once said, perhaps it's better to wake up after all, even to suffer, rather than to remain a dupe to the illusions all one's lives. So with that, I'd like to thank you for watching. And Andy, I guess I'll open it up to questions. Thank you very much.
John, thank you. That was an excellent, very thorough presentation, and I think it really consolidates a lot of research over the years into just this one, it has been an hour-and-a-half long block. If this was a book, I'd tell everybody to get this and put it on your bookshelf. So bookmark this video, refer to it later. A lot of information and stuff to go back and study. So the consequence of having a really great presentation is you're going to take a lot of questions tonight. I hope you're ready. Now, these first couple of them were waiting for us the second we logged on tonight. So let's just address those. First one says, question, do you think that the high temperatures recorded at ground zero after the collapse represent ongoing thermite reactions, residual heat from before the collapse, or something else?
Well, again, NASA took those photographs and they found these very high temperatures at ground zero, which was very unusual, higher than what should have been there from an office fire. So something created that heat. So I'm suggesting that maybe what created that heat was maybe some of that nanothermite. I mean, we know nanothermite was found in the dust. So maybe there was a whole bunch of unreacted nanothermite or thermate, maybe to help pre-weaken that. Maybe it was smoldering away or burning away on some of that massive core columns. And it took a while for it to all burn out, and all the water in the world wouldn't put it out. So yeah, I'm guessing that, yeah, something besides chairs and desks that were in the basements there created that heat, and it had to be something, maybe something that ties to that nanothermite that was found. So yeah, something caused that heat. It wasn't the office chairs.
Next one is, do AE 911T support the claim that 90,000 tons of concrete in WTC1 was reduced to dust, and Harriet's claim that roughly 6%, 5,400 tons of the dust from the tower was iron microspheres?
Well, I don't know what AE, I don't know the exact tonnage. There was a lot of concrete in those floors. Those were open web bar joists with a pan floor on it with a 4-inch topping slab on it. It was 110 floors times 2, 220, each floor was an acre, 220 acres of concrete. Now, Van Romero and the DOD said that that's extremely high explosives. Well, when you have explosives, it fragments things. Anything brittle, concrete's brittle. It didn't fragment the steel. The steel was there in ground zero. We saw that. So yeah, maybe it was painted on. I don't know. Maybe it was, maybe over time, they had plenty of months to prepare for this thing. This is speculation. But yeah, I mean, it could be that a lot of material was put in there as part of construction work, and the workers wouldn't even know. They don't know what they're painting on or applying or whatever they're doing there. So it's very possible that yeah, though that concrete was pulverized as a result of explosions rather than just a gravitational collapse. Take a look at those pictures in my first slide there of an earthquake. It didn't break into powder. It was macro, it was large scale particles. So as far as the percentage of iron microspheres, I'm hearing anywhere from 5 to 6%. Again, why are they round and why are they iron and not steel? It's a byproduct of a thermitic reaction. And if there's nanothermite found in the dust, well, its byproduct is iron microspheres. So that's a high percentage of iron microspheres found. And it wouldn't be found in a normal office fire. So I don't know the exact percentage, but I know there's been a lot of estimates, 5%. But I'm not sure if that's right or not, but I know that's one estimate by Niels Harrit.
Next question, are claims of a pyroclastic flow undermined by a lack of reports of heat or burns by people, report being blown around by the downdraft with dust in their eyes, mouths, and nostrils?
So there was this huge, everybody saw those huge white clouds, those puffy white clouds after those towers came down. Now, it is possible if you have a falling object that you're going to get turbulence in the air and you could get a similar looking cloud. But there's also reports of pretty hot clouds too. I don't have that research with me, but I know it exists. I think AE has that, where people complain about the heat in those clouds. So I didn't say it was a pyroclastic flow. That normally is what happens when a volcano goes off. It was a pyroclastic looking like flow. And what I'm saying is it could have been hot to some of those people there. So I don't know the temperature of those clouds, but yes, I understand that you can also get a similar look when you have some falling objects.
All right, next question says, is it logical to assume that the molten nanothermitic material would have sought the lowest level it could flow to, the 6th-level basement, and started to melt the foundation and bedrock?
I don't know if it would flow there naturally. I think, speculation, I don't know. The only thing I know is thermite will melt steel. I think that it was applied. Now, I also alluded to a possibility. I said that I don't think something like my piston-driven box cutter was bolted to the office walls. Well, that's a no-brainer. You'd see them. And I don't think that the National Geographic, they had just stacks of trash bags laying around full of thermite. And so what I said it's more likely that maybe some of this material was hidden inside those box columns. Well, why would they do that? Those box columns were so huge, going all the way down. Those things were 1,350 feet high, something like that. They were so huge and so massive, it takes a lot to weaken such massive pieces of steel. So maybe, I'm speculating, maybe some thermite or thermate or nanothermite was placed inside those box columns, maybe accessed by the elevator, maybe down in those basements to help pre-weaken it. There was pre-weakening explosions that were heard. A lot of people were in those buildings. They heard explosions in the lobby. A lot of people heard explosions in the lobby before those towers came down. So is it possible that there was thermate, or even better, high explosive nanothermite inside those box columns in the basement that were reacting for a long time and would be difficult to put out by water? I don't think it's impossible. And if it's not impossible, then yeah, that's a possibility.
Next question, along the same lines, talking about the rocks and the foundation there. Rock melts between 600 and 1,300 degrees Celsius, and they have in parentheses 1,100 and 2,400 degrees Fahrenheit. If thermite produces temperatures well in excess of 2,200 degrees Celsius, that's 4,000 degrees Fahrenheit when ignited, wouldn't it have melted the mica schist WTC bedrock?
I don't know. I don't know what the bedrock was, but I mean, let's put it this way. It sure did not melt my container I had on my first experiment. I had just clay tile. It didn't melt that. I think the answer, it depends on how it's configured and how the contact is and how long it is against that rock. I don't have pictures of when those excavators finally got down to the bottom of the basements. I haven't looked at what the rock looked like. Maybe it was. Maybe there was some melting of it. I don't know because I don't have the evidence. So is it possible? Maybe. Maybe some of it did. I don't know the answer to that.
Okay, next question says, Jonathan, if you put a scale under the North Tower, would you see a steady weight loss as more and more mass became part of the falling mass, falling essentially in free fall? And this says the demand increased as the falling mass increased. And I assume demand means the weight increased.
Well, if you go back to the first webinar I put together, and we actually looked at the entire collapse time of around 30 to 32 seconds of the Twin Towers, you'll notice a lot of the material is being blown out away from the Twin Towers. So if there was a gigantic bathroom scale underneath the Twin Towers, as that material is being blown laterally outward, well, yeah, then the overall weight, okay, which is basically the mass divided by gravitational attraction. I think that's right. The weight, as we know it as weight, then yeah, the weight of the tower would be less because obviously you're blowing out material. It'd be like if you stand in a bathroom shower holding a bag of rice and you start throwing that rice off the scale. Well, of course, then the total weight that's registered on the scale will be less. So yeah, you would expect that the weight would be less as that tower is coming down.
Okay, next one says, what do you know about the use of nanothermite in thermobaric weapons? A thermobaric weapon, also called an aerosol bomb, a vacuum bomb, or a fuel air explosive.
Yeah, I think that is absolutely true. If you go to Kevin Ryan's site, digwithin.net, he talks about that. And some of the references, I didn't put them all on there because this presentation was getting kind of long. I just summarized it. Yeah, my understanding is it's also using thermobaric bombs, of which I don't know a lot about.
Next question. In John's great thermite experiments, were any of the CMU blocks under his experiments pitted or sprawled from the thermite?
Yeah, what I used there, I actually used, it wasn't CMU. It was actually concrete cutoffs from a seawall job. And they were pretty thick. They were about, I was going to say 8 inches thick, poured concrete. They were cutoffs. And I used those as a base. I had enough problem putting out the forest fires after this. I used to run around with a hose and had some of my friends out there and my wife putting out fires after I did these things. But yeah, I don't know. You can look at the concrete and it's definitely dark. But it's probably like when the National Geographic and the BBC did their experiment. You can kind of look at the steel beam when they had that open burn there. There's some slag there. Yeah, there's some slag on some of my concrete. But it didn't, I don't recall seeing it spalled, but I didn't focus the energy there either. I focused it on the steel away from the concrete.
All right, now this one kind of goes back to the physics, if you don't mind, so it's not on thermite, but it says in David Chandler's 9/11 anniversary video, Shyam Sunder said the video of WTC-7 showed 3.9 seconds for the roof line to disappear from sight, but John Gross said the video showed 5.4 seconds. Any comments?
Yeah, this is completely off topic here. Just a couple of minor comments. If you look at the World Trade Center, they graphed the elevation of the top roof and they plotted the velocities of it as it went down. And this is a whole new topic that David Chandler and actually Ted Walter knows an awful lot about. And they kind of stretched out their graph of the fall to kind of start maybe a few seconds before its fall. And they kind of stretched this thing out to 5 seconds because they were trying to not allow free fall. Because free fall is another kiss of death with this whole 9/11 thing. If you have free fall, that means all structural support was removed from World Trade Center 7, almost virtually the same time as the University of Alaska Fairbanks pointed out. They all had to be removed. Well, there had to be some force to remove it all. So NIST was desperately trying not to acknowledge free fall. But if you look at their graph, if it's the one I'm thinking of, they broke it into 3 segments, and they actually do have a segment of free fall. And I think it's like for 2 or 2.2 or 2.5 seconds of free fall, which is a lot with the acceleration of gravity at 32.2 feet per second. So I think by them stretching out that graph, they were trying to get around the fact that there was actually free fall, but there's one segment of the fall where it matches what David Chandler had. And in fact, it was free fall. So again, this is kind of off topic, more on the motion, but that's my understanding.
All right, now let's finish up with this one. It is very on topic. It says why, many dots are following, would you ask if thermite can burn through steel beams when it's professionally used to cut steel beams?
Exactly. So the mainstream media is telling you, or they're alluding to you who don't know anything about thermite, don't feel bad, I didn't either, that it couldn't do any damage. The BBC did it, and the National Geographic did it. National Geographic, okay? And they're trying to prove that it can't melt steel. Well, there's what's called thermitic lances that contractors use to cut up steel. What do they use? They use thermite. And I showed you those railroad guys. They know exactly what thermite will do. It's used to weld massive railroad tracks together. And they show them they're welding with thermite. It melts steel. And yet here we have the mainstream media trying to dupe you into believing that it can't melt steel. But yeah, the questioner is exactly right. They make thermitic lances precisely for the purpose of cutting steel.
All right, John, thank you so much. And I just want to remind any engineers out there that you can get credit for viewing this presentation either live or in the archive. You go to ae911truth.org/CPD. Make sure we get the website right there. And you take a short quiz. You got to get 4 out of the 5 questions right. And you'll submit all your information in the process, and you will get your credit. So make sure that you do. But John, thank you so much for this excellent presentation. I'm very impressed, and I'm very impressed by all the people out there who come back time and time again to learn more about this important topic. And we're not going to let it go. We're going to keep on going forward and keep on educating people so they can go forward and demand justice for all the people who died 21 years ago. So for my part, this is Andy Steele with Jonathan Cole saying we'll see you next month with a new presenter in our webinar series. Have a great night.